and it was just having in my tongue tip, right? Just having in my tongue tip, but I forgot. And after some time, you try to remember him. When the neurons started connecting with different direction, finally come to a decision, and suddenly you tell, okay, I know his name, right? So then once you know his name, you will have a good connection, shortest path connection. So you will never forget that person's name again. That is why when the children are very small, we ask them to revise again and again. We ask them to read loudly, right? When they read loudly, they are seeing the book, right? They are seeing the line. So whatever you are seeing through your eyes, it has been recorded on the brain. Whatever you are reading, that sound itself is again going through your ears, and the noise is and the sound signal has been recorded on the brain. And you are moving your lips when you read, that type of movement is also recorded on the brain. So there is lot of way of understanding the brain, right? So it makes you learn more things. That is why we ask to repeat several times. So automatically when you repeat it, strong connection between the neurons happen, and you will never forget a particular answer for a question. Similarly, here you have something called a connection between both the two different neurons, right? And based on the understanding about the neurons on the brain, people started to create artificial neurons, where we will have several inputs received from different neurons. Each input will be represented x1, x2, x3, like that, right? Different neurons will be there. It will be different input values will be there that will be coming from different other neurons. And this will be connected to a particular neuron, right? So the entire part we call it as neuron. This will be connected. All the signals will come to a neuron. When it comes to a neuron, there will be the connection will have a weight. That weight we call it as something called the preference that is being given. As I have already told, when we repeatedly do certain things, we will have that connection will be very strong. This weight will be a very good weight that will help you to give more strength to this particular signal, right? So we will have weights in each of this connection depending upon the strength that we are going to give to each of these input signals, and we will multiply these things, right? X1 into W1, X2 into W2, X3 into W3, Xn into Wn. This sigma will do this particular task. We have sigma Xi Wi. We have sigma Xi Wi. Then most of the neurons will have a bias also. We have a bias input, right? That bias normally either will add or subtract. So this will happen inside the neuron. After summing this up, you will have a transfer function inside the neuron. So entire thing is happening inside this. Entire thing is happening inside a neuron. Several signals are coming to this neuron. Each signal coming there, this connection will have a weight, strength. That strength will be multiplied with that particular signal and added it together. After adding it, you will have a transfer function. So what the transfer function will do, whatever the value that we are having, that entire value will pass through that particular transfer function, and you will get an output. That is why. There are different transfer functions available. You might have learned in the previous classes. One example is something given here, 1 divided by 1 plus e raised to x. So you can have several transfer functions. So when you pass this particular summation value to this transfer function, you will get an output. That output will be the output of this neuron. So this is a neuron. Several inputs are coming, right? And so those signals which are coming will be multiplied with the weight and added it together. You will subtract with the bias value and pass it to a transfer function. After passing to a transfer function, you will get a single output. This will happen in each and every neuron in the neural network. You should remember that. Adding and multiplying with weights and transferring the transfer function will happen in each and every neuron. The transfer function can be very different. You can choose yourself, right? Now, if you see a neural network as it is, this only a few slides are there. Neural network as it is, you can see something called a set of input neurons. We call it as input layer. And the number of neurons in the input layer will be equal to the number of features that you are going to pass to the neural network. If you are having 1000 features that you want to pass to a neural network, you have 1000 neurons on the input layer. Then you have some set of hidden layers. So each hidden layer, if you take, in the hidden layer also you will have so many neurons. It depends upon problem to problem. Either you can try to increase the number of neurons or decrease the number of neurons based on that. So each neuron to neuron, from layer to layer, we have connections. This input layer will be connected to all the hidden neurons in this particular layer, and this particular input neuron will be connected to all the hidden neurons in the first hidden layer, like that. So these all connections will have weights, W1, W2, W3, etc., like that. And similarly, several such type of hidden layers will be there. And finally, we'll have an output layer. The number of neurons in the output layer will be equal to the number of classes that you are having in the classification problem. In a classification problem, suppose you are having 4 classes, then you have 4 neurons. If you are having 2 classes, cancer, non-cancer, tumor, non-tumor, then you have 2 neurons, right? And these connections from the hidden layer will come to this, right? This neuron will connect to these 2 output neurons. This neuron will connect to these 2 output neurons. This neuron will connect to this output neuron. So you have so many connections, and all these connections will have weight. So when you say that you are trying to learn a neural network, you are actually trying to learn the weights. You have set of non-data sets with properties from set of cells. Certain cells will be tumor, certain cells will be non-tumor, right? You will pass all these features to a neural network. The neural network will predict something like wrong results. Then you update the weights. The weights can be updated by certain algorithms already available, like backpropagation algorithms, or you can use some nature-inspired algorithm that you try to improve the weights randomly. And once the weights are all optimized, the neural network will become an optimal model, so that whenever you give some feature, it automatically predict whether it is tumorous, non-tumorous, cancerous, non-cancerous, whether it will weather forecasting, tsunami forecasting, anything. So this neural network is having so much of capability because these concepts they have learned through something called the brain itself. We talk that brain is having 10 raised to 10, 11 neurons, how it works. They are trying to make it computational neurons, right? How it works. So they try to make certain algorithms to try to learn by itself. Several algorithms are there. You might have learned in the previous class. So we want to find the weights. That weight is can be found by having some learning algorithm. One can be backpropagation or some other learning algorithm. You can use it to learn it, or you can use nature-inspired algorithm to improve the weights, right? So this convolution neural network also is an example. Since earlier days, the system performance was very less. We are having very less memory. So those time when even though neural network theory has developed in a very big way, very less application came into picture because it was very difficult to simulate several layers of what is called as hidden layers and several number of hidden neurons. Now, since very good computers have evolved with the GPU computation and very good main memory, people restarted again thinking to have neural network with more number of hidden layers, right? With more number of neurons. And one such type of research is nothing but the convolution neural network, where we have something called filters. And these filters will convolve throughout the images, right? And then try to extract certain features. So here in convolution neural network, what actually learning is to learn the values inside a filter itself. You have several filters, all the filters inside you have some values, that values you have to learn. And similarly, in the end, you can see that there is something called, again, all the neurons that you are having, right? That is being connected to a set of output neurons. There again, you have something called connections. These connections will also have weights. That weight also you want to learn. So filter values, number of filters, right? You need to improve the number of filters. Sometimes you how much filters you want, you don't know. So you can have some nature-inspired algorithm or training algorithm to improve the number of filters and the values inside the filters and the connection weight between the fully connected layer. So these are the things that you want to learn. So we will see a small example so that you will be able to understand those things very clearly. I have a small example for you. Very small example that help you to understand that how simple is to have something called a convolution neural network in MATLAB. Only very 10 lines of code. This is the first line. I will explain detailedly. This is the second line, third line, fourth line. This entire thing is one line because I am not able to make it a single line. I am putting like this, right? This is the fifth line. This is the sixth line. These two things together. This is seventh line, eighth line, ninth line, 10th line. With 10 lines of code, you are able to create a convolution neural network that is able to find out something, a small problem where we are trying to recognize the handwritten digits. Try to recognize something called handwritten digits. Let us see line by line what we are going to do here. And this particular step, right, that is available in MATLAB, full file. It is nothing but which will help you to make a directory where you have stored the folder which is having something called the digits. Right, this is a root or the something called the path that you will get. For example, from the MATLAB root, inside the toolbox, we are having neural network inside NN demos. Inside NN demos, we are having NN data sets. Inside that, you are having digit data set. So the entire path of that particular data set, you will get it here. That is why you are using full file. This is nothing to do with convolution neural network, right? If you eliminate this line, you can say that the entire convolution neural network are able to do with only 9 lines of code. Then there is something called image data store. This function, what it will do is, it will try to get the labels separated as something called based on the labels that it is having, right? So we will have inside the digit data set different folders. For 0, you will have a folder. For 1, you are having folder. For 2, you have a folder. For 3, you have a folder. Rather than naming all the images, 1 minute. Rather than naming each of the images in that particular folder, this image data set will automatically label. For example, in the whatever images that you are having in the 0 folder, where all the images will be handwritten zeros, it will be labeled as 0. All the images that you are having in the folder 1, it will be labeled as 1. And one more thing that you will be able to do with this image data store. If your data set is very big, you assume that you cannot bring all the data set on the main memory. Then this image data set also will support you to have something called incremental way of learning. It will bring small portion of the data set in the main memory, learn the neural network, and again something called batch-wise learning. Small portion, then again another small portion, then again another portion. So even big data, if you are having that is not able to fit on the main memory, this image data store will help you to do that. So these two steps are very important to make that one. First line was to get the, if you have a full path, you can directly give it, or you can use the full file to give the full path. Then the image data store will help you to label it, right? Then this step is to specify how much number of percentage of the things, the records that you are going to give for training, how many you are going to give for testing. Each of the folder is having something called 1,000 number of images. We will see one by one, right? I think we can execute this one. Just I will try to execute this line. I will select entire this line, and I will before that I will clear this workspace I am trying to clear, right? I just clear the workspace and trying to evaluate this thing, right? Once I evaluate, I am running this one, right? Step by step. So once you evaluate, I am having a variable. In that variable, you can see here that you are having the full path where the folder is there. And then I was talking about the image data store, right? We will try to execute this line, and you can see that once you execute this, you will get something called this variable IMDS, right? In this IMDS, we will open it and see what is inside IMDS, right? This IMDS will have information about the various files available in the 0 folder, the 1 folder, 2 folder, 3 folder, like that. In 0 folder, you have all handwritten digits 0. In folder 1, you have all handwritten digits 1, like that. You have around 9,997, right? Approximately like that. So the system itself will be making a label for it, right? So all the information about that will be stored in this particular IMDS. Now we are having another variable that we are trying to make, that since each of the folder is having something called 1,000 images, we want to use 750 images for training and remaining 250 for testing. Suppose 75% and 25% for testing that we want to give, we can specify it here. Now we want to split the dataset into training dataset and testing dataset, right? Or training dataset and validation dataset. For that, you have something called split each label. You have a function in MATLAB, especially Convolution Neural Network Toolbox, which have a split each label, which will, what it will do is automatically divide the entire folder into training folder and testing folder. We need not do manually, right? Because this is all time consuming task. We want to give more importance for research aspect rather than basic aspect. Reading a data is a basic aspect, that since if there's a function already available, you have to use it. And dividing into training set and testing set, we should not write a code for that, because it is also already available, right? Then we have to use that. And we have to give more importance to find out novel algorithm for training. We have to make more time. We have to spend more time in developing methods for learning by itself, and methods for developing novel convolution neural network algorithms. We have to spend more time in developing novel filters, right? Those type of things. We have to spend more time in minimizing the learning time, like that. So all the basic things that is available, you try to use the functions that is available. So this split each label, what it will do is automatically it will split the files into training and validation, right? So you will get what is called as training set and validation set. So we will try to execute this particular step, and we will see that what we are getting. I think we have to run first this one. Then we will try to run this. So line by line we can run, right? So once we run this, you can see that IMDS train is there and IMDS validation is there. So you are able to get two different variables again. This will have information regarding the training data set, and this will have information regarding the validation data set. Now you might have already learned a convolution neural network. Now we want to define the layers, right? Several layers you can define. You can see that each file, that whatever you are having there, the digit size, right? You can even find out what is the digit size. The digit size, each image, when you read it, it is of 28 by 28 size. So once you define the layer, this is the layers you are designing. Once you specify the layers, in the input layer, you have to specify what is the size of the input that you are going to give. Each image is of size 28 by 28 by 1. If it is a color image, you have 28 by 28 into 3. Here you have all black and white images or grayscale images, all grayscale images. The image is of 28 by 28. So that thing you have to give, that telling the input layer, you have to tell that the images are of size 28 by 28 into 1. Then how many convolution layers you want? Convolution layer number 1, right? Convolution layer number 2, convolution layer number 3. So any number of convolution layers. So you can do experiments, right? So we have to spend more times in seeing how many convolution layers we can have. If we increase a convolution layer, whether we will get more results. If we decrease a convolution layer, we will get more results. Like that, you can do a lot of experiments. So you have to spend more time in designing novel convolution neural network learning algorithms, minimizing the learning rate, and trying to find out novel filters. Right, lot of things you can do research. So the first convolution layer you can just specify by saying convolution 2D layer, and you can see that how the convolution is trying to happen, right? Whether you are going to have a convolution of this thing also I will clearly explain based on a slide, right? There is a slide you might have learned already, but still I am having a slide that will help you to understand that how MATLAB does this particular task, right? I will show that. This image, if you are having a function in MATLAB that will help you do something called read image. If you read image, any of the image, you will get the size as 28 by 28. You can use this function to read that. And you try to display that, the images will be like this, 8, 9, 1, 9, 6, something like that, okay? And in the count each label, we have already seen, right? Each folder, how many images are there? If you want to see that, you just have count each label. In addition to that, I am not included in the actual code. You have this function, it will show that in the folder 0, you are having 100 files. Each of the images where 0 will be written. In the folder 1, you are having 1,000 files. In those 1,000 files, 1 will be written. In the folder 2, you have 1,000 files. Each of the file 2 will be written, right? Like that. So you can use this function to say that you see that how many labels are there in each folder. And you will have something called read image, which will help to see the size of the image. And split label, right, that I already explained you. And you have something called this layers. We are talking about the layers. This one single statement, right, single statement. And we will see that what this convolution layer will do. I think detailed explanation you might have already learned, right? So still I would like to say that this convolution layer is the first argument we will say is a filter size, right? First argument that we are going to pass. I will show the MATLAB also. The first argument that we are passing, right? This is 3. This 3 is nothing but the filter size. If you want to have 3 by 3 filter, 5 by 5 filter, 7 by 7 filter, 9 by 9 filter, that is what we are specifying it here, right? So the first argument is filter size, which is the height and width of the filters of the training function, right? So in the example what we have done, we are given as 3, right? Means it is a 3 by 3 filter. And now what we are having is you can specify different size, right? You can even have a square bracket to say about the filter size. The second argument is the number of filters. I told that you can have experiments to increase the number of filters in each layer. You can say that I want only one filter of size 3 by 3. You can say I want 2 filters of size 3 by 3. You can say 5 filters of size 5 by 5, something like that, or 5 filters of size 7 by 7, 7 by 7, something like that. So the second argument is the number of filters you want in each convolution layer. You can see the code again. You can see you are specifying 8. 8 means 8 number of filters you are specifying. Each filter is of size 3 by 3. Right? And the third argument is regarding the padding. Padding means certain times when you place a filter there on the when it is on the leftmost corner on the top side, you will not have values on the leftmost top, because the first middle value will be on the first value of the matrix. I will draw it on the paint and I will show you. I will clear this new, don't save. Okay, I have a matrix like this, right? And I have some values here, 1, 2, 3, something like that. I am going to place a 3 by 3 filter here, right? So 3 by 3 filter, when you place the middle value will coincide at this particular location. So here the matrix is not having any value. Filter is having a value, but this matrix, whatever we are talking about, is not a value in this location. So we need to add something called a pad. We have to increase this matrix in such a way that you have additional padding values here, right? Either it can be 0, 0, 0, 0, 0 padding we will call it, or you can replicate whatever value that you are having, same value you can replicate. Suppose you are having 3 there, you can replicate it here, 3, same 3. So you can repeat it, or you can have something else. So you can have any type of padding there. That padding will is the third parameter that you are having, right? Padding, right? So you see here the third parameter is a padding. Add padding to the input feature map, right? So in the for a convolution layer with a default stride of 1, stride means when you move the filter from one location to another, right? For example, I will again taking this thing. Suppose this filter is located here, right? And once the located here, once you want to move it, again the next position, the center will come here, right? So it means that one position you are moving. So the new filter position will be somewhat here. So when you again stride by 1, so I will use a different color. The central position will come here, and then the filter will be at this particular location. So what it means that you are sliding the entire this filter one by one pixel, right? You can slide by 2 pixel, 2 pixel, 3 pixel, 2 pixel, something like that, right? So that sliding, whatever sliding that we are having, that sliding can be specified by something called same. What stride that you are having. So default it is 1, right? You can say something called same, right? So this is the few things that you are having in this particular convolution 2D layer. You can have 3-dimensional convolution also. That is another, I am not covering it here. Then something called, you are having something called max pooling. This type of convolution layer, any number of things you can have. For example, in the second convolution layer, what I am having is, instead of 8, I am having 16 filters. Right? So this is the thing that we are going to talk about, something called convolution layer. Then the step, this is something called batch normalization layer. So what actually batch normalization you might have already learned, but still I would like to say something. Batch normalization layer normalizes the activations and gradient propagation through a network, making network training an easier optimization problem. So it does something called a normalization step, right? You can avoid certain times. If you want, you can use it. You might have already learned when somebody have taught about the convolution neural network architecture. Now, use batch normalization layers between convolution layer and nonlinearity such as ReLU. This is a transfer function that we use normally. Because other transfer functions, if you use it, there are some disadvantages. ReLU is having some advantages. So most of the convolution neural network can see that ReLU function is there. You might have already seen the theory behind that, right? So, so in the code, you can see that you are having a batch normalization. If you want it, you just want to call that batch normalization layer semicolon. That's all. Then if you want to have ReLU, some other transfer function you have, if you want, the MATLAB provides those functions also. You just want to call that. What transfer function you want, you just call by that name. So we want ReLU layer, we just say ReLU layer. Finished. So we have an input layer, we have a convolution layer. When we do the batch normalization, then we do have a ReLU layer. Then we do something called max pooling. But here also max pooling filter size, whether it is 2 by 2 filter, 3 by 3 filter, 4 by filter, for pooling filter, whatever window that you want to specify, that you can specify here. And stride, how much movement it want to make. 1 pixel it want to move, 2 pixel it want to move, 3 pixel it want to move. You can specify the stride size also, right? How much it should move, vertically and horizontally also. So this max pooling layer also I will show. You might have already heard about that in the in the theoretical class. Suppose I will show in the paint you a small example I will show you so that you will be able to understand clearly, right? You have a matrix, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Like that, a big matrix will be there. Suppose if you want to have something called the window, that 3 by 3 window, suppose it is residing somewhat here, right? Same on the top of this. Then suppose you are using something called max pooling. In this particular window, whatever value is maximum, that will come here on the region. So here we are having 9, so you will get something called 9. If it is min pooling, you will get the minimum value. If it is average pooling, you will get an average value. And whatever type of your own way of pooling also you can do it, depending upon your need. And this window will keep on moving, right? This it will stride to the next level. If you give striding as 1, it will move 1 pixel. If you give striding as 2, it will move 2 pixels, right? Like that. So that is what this striding will do. We will again go to the code. So you have a max pooling layer. You can have min pooling layer, whatever layer you want. This is 2D. If you are in 3D, you can have max pooling 3D layer, something like that. What is the window size, 2 by 2 or 3 by 3, you can specify. And whether it should stride to 2 step or 3 steps, you can say like that. So again, one more convolution layer, right? Again, batch normalization layer, again, relief layer, then max pooling layer again. Here again, you are having 2 by 2 max pooling. Then again, convolution layer with 32 filters, right? 32 filters we are having. Then again, batch normalization, relief layer. Then again, fully connected layer. How many fully connected things you want, you can specify here. Then you have something called softmax layer, right? This softmax layer, again, you want to understand it. I think in theoretical part you might have learned it. Still, I will show you. So it is something called an activation function which normalizes the output value to the fully connected layer. And the softmax layer consists of positive numbers that sum to 1. So if you add all the values that is coming outside of the softmax layer, it will sum to 1, right? So it will help to improve the classification rate. So that what we are doing here, we have something called a softmax layer. Then finally, classification layer. The classification layer finally will have the new number of neurons equivalent to the number of classes that we want. So this is entirely one single line actually, right? One single statement, semicolon you can see here. Starting the bracket here, ending the bracket here. So first we have a path, then we have divided in, then we have labeled all the data sets. Then we have chosen how much we want to for training and testing, and we divided the entire data set. This number of train files you can see here, right? Divided 750 number of images in each folder is for training, 250 images for validation. Then we have defined how our layers should be. If you want to increase the convolution layer, you can increase there, right? So if you want to increase the number of filters, you can increase there. If you want to increase or decrease the filter size, right? 3 by 3, 5 by 5, 7 by 7, you can do that. Then now comes the training option. This entire thing is a single line where we specify that what algorithm we want to use. There are a lot of algorithms for learning convolution neural network. This SGDM is one particular type of algorithm, right? And what learning rate? Learning rate is how much fast the weight should be updated. So this learning rate we can specify, and how many epochs we want to do. More number of times we want to do continuously do this experiment to learn the weights, that we can specify how many epochs we want, and whether we want to shuffle each time that the values that we are having, and for every epoch, right? Whether we want to shuffle, and the validation data. Where is the validation data we want to specify, right? We are having IMDS validation that we want to specify here, right? And validation frequency, how often we want to validate, right? We are running one time, we are having some error, whether we want to validate there and do that. So the validation frequency we can specify, And there are some other parameters inside that, right? Whether we want to plot in between, we want to plot the training progress and all these things we can specify. So then there are options for training. There are a lot of other options are also available. If you want to know more about it, go to the MATLAB and you have a help file and you can know that. Even Google search, you will get the help file for MATLAB based convolution neural network. Then this single statement will train the entire neural network. Earlier, we have just specified the options, we have specified the layer, we have specified the path where it is available, we are divided into what is called as training set and learning set, and we have specified also that learning algorithm. Now this single statement will train the entire neural network, where we want to specify the training data set, we want to specify these layers what we have defined here, and we have to give the options. Once you give that, this statement will help you to do what is called as a training, entire training. Then after doing the training, we want to validate how much good it is, right? The validation, you give it here. This is the trained model. This trained model, you put it here in the classify function, you will get the predicted result. So once you get the predicted results, you try to find out the labels of that predicted result, and you have that predicted labels. This predicted labels, you put it here and see that how much is the accuracy. This is how you, there are a lot of ways of finding the accuracy. This is the way you find accuracy here. This is something called 10 lines of code. This is first line, second line, third line, fourth line. This entire thing is one line, right? Fifth line, this second two, undo, sorry. Undo. This entire thing is another line, this one another line, this another line, like that, right? With the 10 lines of code. We are able to do that. We will run this and see how good it is able to classify. What is a classification percentage for digit classification, right? The data set is defaultly available in MATLAB. If you are using MATLAB, you can use the same data set. No need to download from anywhere. So now it is running. So depending upon whether you are having GPU or non-GPU, you can, even in options, you can specify whether you are having GPU computer or not. Certain times it will, if you are not mentioning anything, if there is GPU, it automatically take. Defaultly, it will automatically take. So once you see this learning, right, it is now automatically, once we run that, it tries to initialize the things and it starts training. So we will be able to see on the screen. Here you can see that hardware resources, single GPU, single CPU, right? Since I have not mentioned anything about GPU, if you mention you want to have GPU, it will automatically run in GPU. When you run in GPU, it will be very fast. If you run in GPU, it will be fast. So there are options which you can mention in the option, right, where you can mention you are having GPU. So automatically you take care about the GPU component and it will run parallelly, and your simulation will be very fast. And this is the accuracy, it is increasing, right? Accuracy percentage, training accuracy, and this is the loss that you are able to see here. And on the right hand side, you can see the epochs, the number of things, maximum iteration it is going, and all these things you can see here. Right, once you see there, you can see their accuracy 98.32. So since we are having only very few time, I'm not going deeply inside any of the things. This is the few things that I want to talk regarding the convolution neural network. Now you can understand that